Welcome to Signal Science System subject classes. Now we are in the third chapter, that is continuous time Fourier series. So in the chapter, this is the last class. So in this class, we are revising the this whole chapter. So this is a revision class. So I'm starting from the Fourier series representation. You know very well. So you know that Fourier series coefficient. So Fourier series representation. It is for the continuous time to the frequency domain signal, is it? So for a series, it converts the time domain to the frequency domain, is it? So time domain to the frequency domain and frequency domain to the time domain. That you know very well. So now, and it is applicable for the, so it is applicable for the, applicable for periodic signal. That you should remember, this one is periodic signal. So any time period, any periodic signal can be represented in terms of the complex exponential. So that is nothing but the Fourier series representation. Simple. So x of t, it is a periodic signal. So it can be written as complex exponential, is it? So e power jk omega naught into t to ak. This is the Fourier series coefficient, is it? K from the minus infinity to plus infinity, is it? Here omega naught equal to 2 pi by time period, capital T. So this is the Fourier series representation. So this is Fourier series representation, is it? Then Fourier series coefficient formula AK equal to 1 by T integral of within the time period, is it? So this is T. So x of t into e power minus j k omega naught into t into dt. So integration, is it? This is the Fourier series coefficient formula. So Fourier series coefficient. So Fourier series coefficient. Then next formulas, some basic signals. For example, one rectangular pulse train, already we done that. So for example, so it has a magnitude within the minus t1 to the t1, is it? So that we can write mod t less than t1. So it means that it from the minus t1 to t1, that magnitude equal 1. 0 from the t1 to the t by 2, is it? For the positive and negative. So mod, so t by 2. So this is the time period, is it? For that, for this, the AK formula equal to 2 sine k omega naught into T1 by k omega naught into T. So this is the Fourier series coefficient for this periodic signal, is it? Another signal, here I am taking impulse train, is it? Impulse train. So x of t equal to, so sigma del of t minus n into t. So this is the impulse train. So n equal to minus infinity to plus infinity. For this, the Fourier coefficient formula AK equal to 1 by t. Is it? Next, properties. So before going to the properties, I'm taking two signals. So for one x of t, its Fourier series coefficient equal to AK, and another signal y of t, its Fourier series coefficient equal to BK. Is it? Fourier series. Right. Next, properties. So, properties of, is it? So, the first property, linearity. So, linearity, you know that for the linearity, it should follow the scaling and additivity property, is it? So, A into X of t, one signal. So, this is a coefficient. And this is additivity property, B into Y of t, that equal to, that Fourier series coefficient equal to, so it follows the scaling and additivity. So then, so A, X of t Fourier series coefficient equal to AK, then additivity property, B coefficient, and Y of t Fourier series coefficient equal to PK. So this is linearity property. Time shifting property. So time shifting, time shifting, already we have taken X of t Fourier series coefficient AK, then here first time I'm taking the delay. Is it this X of t minus T naught is a delayed of the X of t by the T naught unit? Is it? Then so AK its corresponding Fourier coefficient equal to AK into e power minus JK omega naught into T naught. Is it T naught? Is it? So this whole it is a function of the K. So similarly, we can write for the advanced signal. So this is advanced signal by the T naught. So for this, AK into e power jk omega naught into T naught. For the minus here plus to plus, is it? So next third one, frequency shifting. Frequency shifting property. So frequency shifting. So shifting in the frequency domain. Here I'm taking A k minus m, is it? In previously I have taken the k minus k naught, is it? So m is the constant. So for the corresponding signal in the time domain, that equal to x of t into e power, here minus, so here we will get the positive e power. So in the place of the k, should write the constant m into omega naught into t. So this is the Fourier series. The next one is conjugation, complex conjugation. So conjugation. So x of t, here we're taking the complex conjugation for the in time domain. The corresponding is A minus k complex conjugation. So fifth one is time reversal. So time reversal. So that equal to x of minus t. So it goes to the A of minus k. The sixth one is time scaling. Time. So time scaling. So x of alpha t, its Fourier series coefficient. There is no change in the Fourier series coefficient. So x of t Fourier series equal to ak. Here also x of alpha t Fourier series coefficient also same, but there is only change in the time period. The resultant time period t dash equal to t by alpha. Is it? Previous the number is sixth one, time scaling. Now seventh one. So seventh one is periodic convolution. So periodic convolution. So periodic convolution, in the time period it is a convolution. So x of tau, y of t minus tau. So this is that into, so t, is it? So in for periodic convolution in time, the corresponding for in frequency domain, this is the multiplication, is it? T into ak into bk. So next eighth one, multiplication. So multiplication in the time domain. So multiplication in the time domain. So that equal to x of t, so y of t. So corresponding in the frequency domain, that is a convolution, is it? So ak convolution bk. then directly I am applying the convolution. AL BK minus L from the minus infinity to plus infinity digits. So this is a convolution formula. So next one, differentiation. Differentiation. So in differentiation, so d by dt of x of t, is it? So x of t Fourier is coefficient into ak. So for the differentiation, jk omega naught will be multiplied, is it? So next, integration. So integration. So integral of x of tau into d tau minus infinity to t. So its Fourier is coefficient. So x of t Fourier is coefficient equal to ak, and integration of x of tau. So jk omega naught. So ak divided by the jk omega naught. Next, 11th one, conjugate symmetry. So conjugate symmetry. So in conjugate symmetry, so x of t is a real. So this is the x of t real. Then ak equal to, so a minus k complex conjugate, it becomes the ak, is it? So real part of ak equal to real part of a minus k, and imaginary part of ak it equal to minus imaginary part of a minus k, and the mod of ak it is equal to the mod of a minus k. And so what is the difference between ak and a minus k? Just a minus k, just replace the k minus k in place of the k. That is a minus k. So the angle of ak that equal to minus angle of a minus k. So this is a conjugate symmetry. Next, realigned even signal. Realigned even, is it? X of t real and even, then ak also real and even. There is no change for the even, is it? Next, real and odd. So x of t real and odd. For that, ak becomes purely imaginary. And it is a odd. Is the magnitude is odd. Next, even and odd decomposition of real signal. So even part of x of t, or so even part of x of t. So its Fourier is coefficient. It is equal to real part of ak. So the odd part that equal to is nothing but, so odd part of x of t. So this xc of t is nothing but even part. X naught of t is nothing but odd part of the x of t. So its Fourier is coefficient is, so Fourier series coefficient j into imaginary part of ak. You know that the sum of the, see the xce plus x naught that equal to x of t, is it? So its Fourier series coefficient equal to the sum, is it? So real part ak plus j into imaginary, it becomes ak, is it? So last one, Parseval's relation. So Parseval's relation, it is a relation for the power between the time domain signal and frequency domain relation. So you should write in left side in time domain. So first write down the formula for the x of t representation. You know, so sigma ak mod into square. The mod of the exponential goes to 1, is it? K from minus infinity to plus infinity. Now write down AK formula. So that equal to 1 by T integral of T mod of square. The mod of the exponential, it goes to 1, is it? So this is about continuous time Fourier series. Okay. In next class, we will start discrete time Fourier series. Thank you.